Hi, I'm Mehul Shah, the General Manager of AWS Glue and AWS Lake Formation. And today, I'm going to tell you about AWS Glue and how it provides serverless data preparation capabilities. Before I get started, let me give you an overview of my talk. First, I'm going to tell you about AWS Glue and the modern use cases that are driving its growth. Then, for the bulk of my talk, I'm going to be speaking about some of the cool new features it offers to make Glue faster, cheaper, and easier to use for you. And then finally, I'm going to conclude. So why data preparation? What is data preparation? Data preparation is the process of collecting all the data that you need, transforming it, cleaning it, and normalizing it so you can get quality in that data for running analytics, to get insights about your business, understand how it's operating and what you can do to optimize it, and to build machine learning models so that you can do prediction and classification. Data preparation is the first mile of any of these activities. And data preparation is hard. If you don't get it right, you're going to end up with incorrect results. So what are the factors that make it hard? Well, there's three of them. The first one is that there's lots of data. Across our customer base, we see our customers increasing the amount of data that they manage, growing the amount of data they manage by 10x every 5 years. And this data is becoming increasingly diverse. It's no longer just structured data that they want to manage or analyze. They want to analyze semi-structured data. This is data like machine logs, network logs, IoT device events, click streams, mobile events, and social feeds. They also want to analyze unstructured data like text. And for most data preparation projects, there's always some amount of customization that you need. It's not a simple one-click-and-go process. And we find our customers end up writing hand-coded scripts for most of their data preparation jobs. And these scripts tend to be brittle and error-prone as the data evolves. And then finally, many of our customers are still managing their own infrastructure. They're managing their own virtual machines, sizing them. They're building their own clusters and managing their life cycle. They're scheduling jobs on those clusters, monitoring them, making sure they're running successfully, and then building a variety of metadata stores so they can organize their data and manage those metadata stores themselves. And so as we saw that back in 2017, we decided to build and launch AWS Glue. And Glue at that time was billed as a fully managed extract, transform, and load service, or ETL for short. It was designed for developers, programmers. People like us were also developers and programmers, and we knew what was necessary to get this job done. Since then, you, our customers, have pulled us in many different directions. And in particular, you've told us that you want to broaden the service. It's more general now. It's a serverless data preparation service. And it not only serves data engineers and programmers, but it also serves ETL specialists, data scientists, business analysts, and more. You actually helped us grow. Today, we have hundreds of thousands of active customers on the Glue service, running millions of jobs on a daily basis, and Glue is available in 22 regions across the globe. Here's a selection, a small subset of some of the customers and partners that are on our service. You can see that these enterprises span the gamut, from small to big, from financial services, from the auto industry, from media companies, and so on and so forth. Glue is applicable in a lot more contexts than a single vertical. And we really want to thank you for all the things that you've said and for noticing all the things that we've done over the past 2 years. Here's what you've been saying in many different languages and many different ways. Glue is faster, cheaper, and better than ever. Thank you so much. So let me tell you a little bit about the modern use cases that are driving the growth for Glue. Before I get there, let me quickly give you an overview of what Glue and its components are. The first main central piece of Glue is its serverless ETL engine that's based on Apache Spark. You basically give us your Apache Spark scripts, or you can just give us pure Python scripts as well. We automatically spin up the servers that are necessary to run those scripts, determine the capacity that's necessary, execute it, you pay for what you use, and then we shut those machines down for you. We manage the entire life cycle, entirely serverless. We also give you a visual tool, or a number of visual tools, to interactively develop your jobs, and we'll automatically compile those jobs down to Apache Spark scripts that run on our scalable big data infrastructure. We also give you a Glue data catalog. What this is a centralized metadata store, fully managed. It's Hive Metastore compatible, and there are a number of AWS services that are already integrated with this store, as well as third-party partners, as well as open source tools. We also provide crawlers that automatically scan your S3 buckets, your databases, infer the schema for your data, the table structures, and then automatically load the data catalog for you. It also supports schema evolution. And then finally, you can put all this stuff together into complex workflows to run your data pipelines in a reliable fashion. This is our Glue workflows component. What's Glue used for? Well, there are three main use cases that we can see. The first one is for building data lakes on AWS. You see, we find a lot of our customers taking all of their data and putting it into Amazon S3, which is this ubiquitous, low-cost, highly durable, with 11 nines of durability object store. They're breaking their data silos in their operational databases and using Glue to ingest data from those data silos into S3 and then process that data from stage to stage and refine it. Then finally, when it's ready for production, what they'll do is they'll run Glue crawlers to load and maintain the data catalog that points to all this data. And they'll use a sister service called AWS Lake Formation to secure the data lake and the data that they've created, the data lake that they've created. And then a number of analytic services that we have integrate with Glue and Lake Formation so you can access that data securely and analyze it. We have Amazon QuickSight that allows you to do business intelligence, Amazon Athena that allows you to do SQL querying over your data warehouse in a serverless fashion, EMR that allows you to do big data processing, Amazon Redshift that allows you to do data warehousing, and SageMaker that allows you to do ML. We also find our customers loading data warehouses with AWS Glue. Typical ETL processing. They're getting data out of their operational databases like Amazon Aurora, combining it with Amazon S3, loading their enterprise data warehouse so they can run daily or nightly reports. And increasingly, we see our customers running data preparation for AI, ML, and data science workloads. We see them cleaning and enriching their data, extracting features and separate training sets so that they can build their ML models, and then they're taking their data and running inference, prediction, and classification using Glue, or using Glue to drive the data into the ML services. We also see customers having their data scientists use notebooks connected to Glue for data exploration and data experimentation so that they can come up with new ways of analyzing their data. All right, so now that you know what Glue is used for, let's talk about some of the recent innovations that we've added into Glue. Since 2 years ago, when we last talked to you about Glue and its features, we've actually added over 50 new major features to Glue and a number of new regions. And there are three trends that are driving these new features. The first trend is that when we first started, you're putting more demanding workloads onto our service. When we first started, most of the jobs that you were running were basically latency agnostic, long-running, nightly or hourly ETL jobs for loading your data warehouse, for loading your data lakes, and running reports. And so our original engine, 0.9, and the next version, 1.0, really was great because it allowed you to do that in a serverless fashion without having to go spin up any machines. Job startup was tolerable on the order of, tens of minutes, if you will. And we had a 10-minute minimum billing duration. Well, since then, you've put a lot more real-time micro-batch workloads on Glue. And these workloads are latency sensitive and require, in some ways, continuous operation. So you can build things like responsive dashboards, do monitoring and alerting, and build other kinds of streaming or semi-streaming applications. And so the old engines aren't really going to be able to support these kinds of workload demands. And so we built a brand new engine for you in the summer. We released Glue 2.0, a new engine for micro-batch, new real-time workloads. Okay. What's better? Well, almost everything is better about this engine. It starts up 10x faster, is much more predictable, and it's more cost effective. We've dropped the minimum billing duration to 1 minute from 10 minutes. And for customers that have moved over to Glue 2.0, they see an average of 45% cost savings. So now they can actually run their latency sensitive workloads at a much cheaper rate. We've built a brand new job execution engine underneath the covers to make this all work, and I'm going to tell you about that. But before I get there, let me tell you how Spark works so you have some background. When Glue actually runs a job on Spark, what Spark does is actually takes those scripts and breaks it up. Spark is a data parallel system, so it's going to take those scripts or your jobs and divide them into stages. And each stage is going to run over your data, and your data is going to be partitioned or into shards. And so for each stage and for each partition, there's going to be a single task that's going to be ready for execution. And what the Spark scheduler does is it takes those tasks and executes them or schedules them on executors, which are attached to virtual machines that comprise your cluster. All right, so for the previous version of Glue, 0.9 and 1.0, what we were doing was we were actually sending those jobs to our job manager, and the job manager was scheduling it on a cluster, and it would pick a cluster from 3 different mechanisms. Either the cluster was already allocated to a particular user and a customer, in which case your job startup would be on the order of a few seconds, or it would go and take a cluster from an already provisioned cluster in our warm pool, attach it to a user and its job, and then start running, in which case it would take tens of seconds. Or we would spin up a brand new cluster from EC2 on demand, in which case startup time would take on the order of minutes. And then we would submit the job or the script to the cluster, Spark would take over, and it would start doing the scheduling of the tasks to the executors. When you did it this way, what happens is that you have high latency because your job only starts after the entire cluster is provisioned. And if you end up needing capacity that's not within the sort of t-shirt size clusters that we have in our warm pool, you're going to end up actually going to EC2 to wait for the cluster to get built up. And so that leads into high latency and high variability. Glue 2.0 is completely different. Okay, so Glue 2.0 actually integrates the scheduling of the tasks with the provisioning of the machines. Let me show you how. You submit the job to the job manager. The job manager then submits the job to a virtual cluster. Now, if that cluster already has some machines set up, the job starts immediately. The Spark scheduler will start working, and it will ask for tasks to be attached to executors. And if it needs a new executor and the executor doesn't have any machines, to be attached to, then we're going to dynamically grow the virtual cluster. We're going to go to the warm pool, and now we don't actually have to go and get another cluster. We can get one machine at a time. So our warm pools are much more flexible and spread across multiple AZs for additional resiliency. And the warm pool already has a pre-configured machines with Spark on them. But if you can't find a machine in the warm pool, or it's depleted, you can go to EC2 and get it on demand. And if you go to the warm pool, the startup time is in the order of a couple of seconds. And if you go to EC2, it's on the order of tens of seconds. Once the virtual machine is provisioned, we will then schedule the executor on that machine and then the task on the executor, and the Spark will start working with that cluster as it grows. So the cool thing here is the job starts when the first executor is ready. So your start time is reduced, and the variance in your start time is also reduced. The other nice thing is you can operate your job. It'll actually run and make progress even when it's not in full capacity. For example, when it's starting up or when there's some kind of unavailability. In that case, it'll still continue to make progress, and so it gives you graceful degradation. All right, let's compare the two. At the top, we have the distribution of job startup times for 1.0, and on the bottom for 2.0. Now, the scales on the x-axis are not actually aligned properly, but that's okay. We'll fix that in a second. There are three things to notice here. If you get a job that gets executed on an existing cluster, and this is in most of the cases, then the startup times are going to be short. We call this warm start. If you end up hitting the warm pool, it'll be a little bit slower, and that's the second hump that you see, but it's still pretty fast. And then, of course, if you need to go provision new machines and you need to go and configure them, and you're going to EC2, it's going to take much longer. With Glue 2.0 and versus Glue 1.0, you see a different distribution. The reason the 1.0 distribution for cold start is much wider is because every job is going to have a different capacity that it needs, and so it's going to only start when the entire cluster is provisioned, so you're going to have this wide distribution of start times. While with 1.0, you start the job almost immediately as soon as a machine is ready, so the distribution is much narrower. And actually, if we had to actually fix the timescales, you'll see that with 2.0, everything is just flat out much faster. The warm start is under 10 seconds compared to 1 minute for Glue 1.0. And Glue 1.0 job start times for cold start are on the order of 8 to 10 minutes on average, while with Glue 2.0, it's under or around 30-35 seconds. So it's literally an order of magnitude faster. We have a number of customers that have moved over to Glue 2.0, Ibotta, and Marketing Evolution, and they can confirm that start times are much faster, they're saving a lot more money, and the system is much more reliable and resilient. All right, the second trend I want to talk about is the fact that you have many more types of personas. Our customers have many more types of personas that want to be able to use Glue and its powerful serverless engine. Not just engineers, but also ETL specialists, data scientists, and business analysts. And for them, we launched a brand new interface to Glue called Glue Studio. It's a visual interface for building ETL jobs, for Glue jobs. You basically draw or diagram out an ETL workflow visually without ever having to code. You basically get a canvas-based tools where you can actually diagram it out. And we also give you ways to drop in specialized code for advanced transformations that the visual tool can't easily express. So you can do this entirely without coding, but if you want to code, that's also an option. We also allow you to monitor thousands of jobs through a single pane of glass. And then we convert these workflows into Apache Spark scripts so you can still take advantage of the distributed processing of Spark without actually having the learning curve. Let's give you an example of how this works. In this example, what we're going to do is we're going to take ventilator readings from hospital ventilators, put them into a stream. We're going to enrich them with hospital information and then store them in S3 so we can subsequently analyze how well our ventilators are doing in a hospital system. We're going to consume the data from two different sources, one which is a streaming source and the second one which is a static source which is in a relational database, combine it using a join, clean it using some ML, and then store it in S3, monitor the jobs, and then analyzing the resulting data set. If you take a look at the ventilator readings, the raw readings are going to be in JSON format, and it's going to have a bunch of different fields that tell you or identify the ventilator, some of the metrics that the ventilator is, the manufacturer, the hospital that ventilator is in, and then the operating status. Now, depending on the ventilator, some ventilators actually give you an operating status and other ones don't because they're just manufactured differently. And so in the real data, you're going to see empty fields. This is how real data is dirty. So let's show you how you can actually clean it up and process it using Studio. This is what you get with Studio. You get a blank canvas, and then you can basically start adding nodes to build up a graph. Node, there are 3 different types of nodes: sources, transformations, and targets. In this case, the source is going to be a ventilator stream coming from a kinesis stream. And if you want to take a look at the output of that data set and what its schema looks like, you can actually look at the output schema directly in Glue Studio. The hospital information is actually going to come from a data set that's sitting in the public AWS COVID-19 data lake. We're going to store it in an RDS database. It's basically structured data about the hospitals across the US. It's an RDS database, so we're going to create a new source, configure it to be an RDS source. And then we're going to combine those 2 data sets based on a transformation called a join. And what we're going to do is we're going to take the records that are coming in from the ventilator and join them on the hospital ID with the hospital information that's in the relational database that's there. And then finally, those missing values, we're actually going to go and drop in a custom transformation. This custom transformation allows you to write Python code or Scala code. In this case, we've written Python code. We're actually calling upon a library that's embedded with Glue ETL that automatically fills in missing values. It's called imputer. And what it does is it automatically trains itself on data that's streaming through, and based on the values of the other columns that it sees, it's going to try to predict what the value for operating status is going to be. 10 lines of code, and you can automatically, pretty quickly use ML to clean your data. All right, then the output is going to go into an S3 bucket, and we're going to organize the output by state and also by event time. So all those records are going to be distributed across different directories so that when we analyze them, we can go to the directories of interest to reduce the amount of data that we have to process and analyze. Here's what the monitoring dashboard looks like. It gives you a single pane of glass that tells you what's going on in your entire system. Number of jobs that have succeeded and failed, how many are running, and there are different views here where you can come in and drill down and find the jobs of interest to understand their details and what's going on. You can also attach a notebook to quickly analyze the data using Glue that's sitting in your S3 buckets. In this case, what we're showing you are the missing values that were imputed. You'll see that the nulls have been turned into OKs or warnings based on the other column values that you see on the left-hand side. And then through those notebooks, you can also run analyses. In this particular case, you're running a 5-minute window analysis showing you the number of unhealthy ventilators in that 5-minute window. And you can run this on a continuous basis. We have a number of customers using Glue Studio across their organization, and they confirm that it's much easier, much faster, and much quicker to deploy jobs using Studio than before because the learning curve is much, much less, and you don't have to actually know Spark to get started. All right, now the third trend is that we're seeing our customers store more and more data with the Glue Data Catalog. And the Glue Data Catalog is something that actually keeps track of your table structures, including your partitions. Partitions are effectively directories. This is what we did in the last example. I'm going to use the same thing here. And what you do is you put your data into different directories so you can get to that data very quickly when you're doing analysis. So originally, people had sort of a manageable number of partitions in their data catalog, tens of thousands, if you will. Here's an example where we've organized our data based on region, year, month, and day. But increasingly, with microbatch workloads and more data coming into the system, we see customers storing nearly hundreds of thousands, if not millions of partitions with the data catalog. and adding additional levels of granularity, like fine-grained partitions here, not just based on day, but also by hour, sometimes minute and second. And so the number of partitions have exploded, and that's affected how you can do analytics with the Glue data catalog. Let's see how that works. Imagine, for example, you're using EMR Spark to run a query. You submit the query, Spark will consult the data catalog, and the data catalog will then scan through all the partitions it has to find the relevant ones and then send them back to Spark. And that's the query planning phase. Then it's going to execute the query, retrieve the data, and send the results back. Well, query planning here is going to be proportional to the time it takes to scan through all the partitions. And if you have millions of partitions, this can be significant. And of course, if you ask queries where you're looking at or asking for things like just at the leaves of the partitions, then you actually have to scan through all of them. You can't very quickly pinpoint which partitions matter. And so it's going to take a while. What we added is a new feature called partition indexes. Partition indexes basically improve the query planning phrase. You can create partition indexes on any partition column or any combination of partition columns. In this case, we've created one on year, month, day, and hour. You can create as many of them as you want, so you can add region and category for another one. And the nice cool thing about partition indexes is they also support range-based predicates. So you can very quickly narrow down, for example, all of the partitions that span from, say, 10 a.m. to, say, 1 p.m. EMR Hive and EMR Spark use partition indexes today, and more applications are to come. Let's see the impact of partition indexes on a real-world-like query. Here's a query where we're trying to count the number of IoT devices that are actually sending out data. And in this particular case, we're looking for literally just 1 day's worth of data here in November. And when we had about 50K partitions in this data set, with or without a partition index, the query took roughly 7 seconds. Manageable. But as we scaled the number of partitions, when we went from days to minutes and hours in our partition list, it turns out that the query time without a partition index started blowing up. Went from 7 seconds to nearly 64 seconds. As we dig a little bit deeper, what you see is the runtime, which is in orange, stayed roughly the same, about 7 seconds. But the query planning time blew up, added another 50 seconds of latency. And so by using an index, you were able to save 99% in running your query. So depending on how big your partitions are and how big your runtime is for your query, you can literally see orders of magnitude improvement in your query planning. And certainly some of our bigger customers have seen this. For example, VMware has a petabyte scale data lake on S3, and previously they couldn't run their analytics based on tight SLAs, and now they can because they're using partition indexes. All right, now one last thing. I want to introduce a brand new feature. It's going to be available the end of December in 2020, and it's called Glue Custom Connectors. Prior to this, if you wanted to connect to on-premise databases that we didn't have first-class support for, or proprietary stores, or SaaS applications like Salesforce and ServiceNow, you had to be a Spark expert. Well, now you can have a connector that you can build on your own and reuse in Glue Studio, or you can pick up a connector from AWS Marketplace, where there's a bunch of third parties that have developed connectors, and you can use it directly in Glue Studio to access the data. We have a variety of connectors that we support. We support Athena data source interface connectors, where you basically have to fill out about 6 different interfaces. We support Spark Data Source v2 interface connectors, and we also support connectors from the AWS Marketplace. And how does it work? Well, you simply register the connector or create a connector in Glue Studio. You create a job using one of those connectors, configure the connector, and off you go. Pretty simple. Now I want to briefly touch on 2 new capabilities in Glue. The first is Glue Data Brew. It's a new visual interface for cleaning and normalizing your data. It profiles your data to detect patterns and anomalies, and you can choose from over 250 built-in cleaning transforms and visually apply them at scale. With this and Glue Studio, Glue is a one-stop shop for authoring end-to-end data preparation pipelines. The second new capability is the Glue Schema Registry with the data catalog. What it allows you to do is it allows you to enforce schema evolution rules for schemas in your data catalog, and this is useful for getting data quality for your streaming applications, for getting data quality when you're processing streams from Kafka, Kinesis, and running Kinesis Data Analytics or Apache Flink. All right, now to conclude. I've told you about a number of new features that have made Glue faster and cheaper. We've shown you tools that make Glue accessible to non-programmers, ETL specialists, data scientists, and data analysts. We've shown you new features to speed up your analytics using Glue. And now we're going to release Glue custom connectors that allow you to access hundreds of data sources with Glue. Glue now supports multiple personas and use cases with persona-specific journeys that go beyond developers to let you continue to break down silos and enable collaboration in your organization. I recommend that you check out Glue at the following website. And if you're interested, check out these other sessions in reInvent where customers have used Glue in production with a tremendous amount of success. Thank you so much. And if you're interested, please complete the session survey at the end of the talk. Thank you.